Is that? Yes, okay. So, by the end of tonight, this should work. I've already kind of started on it by the parser at least recognizes that this type directive is a thing. But that's about all I have for support for that right now. So if I try to compile this, we are yes, so we don't fail here, we know what this is, but parsing structs, it's expecting a curly brace after this, and it's seeing all this stuff and does not know what it is. So let's go to parse struct and start letting it do that. Here, let's not expect that. Let's expect either let's grab the next token and say let's do this. Equals let's just assume it's not and pick out the ones that are. So it's an open curly or an open paren. It's valid, and actually, no, let's not do this. Let's keep doing what we were doing exactly as is, because even in a case where we have types to pass, we still at the end of the day want to parse the rest of it like normal. So before we look for that, let's just look for the other stuff. Right, so like if the next is a semicolon, we just end it. If it's a open paren, we're gonna do some other stuff. So I think we can just parse this like we do function parameters. Let's look and see function params. Parameters. Function call params. I want decal params though, yeah. So we assume that we've already eaten the open paren, so let's go ahead and skip it. And then grab the next one. Well, no, we can do that. We'll do that here before we move on. We will just expect if there's an open paren, this will put us at the end of it afterwards. Does this do what we want it to do though? We look for close, comma, and variable decals, and they get turned into params. I'm fine with that. These can be params. So let's do that. Let's Maybe we rename this though to parse paramdecals or something. We only do that in 2 places, so we can do that here as well. Parse paramdecals, pass it the parser and our struct, which is struct node. Now, what I don't know is parse paramdecals. Does this end us past the closing paren? No, it doesn't. It puts us at the closing paren. So we will just do this. So if we see an open paren, we're going to skip it, parse paramdecals, and then we should be at a closing paren at that point, so we can skip past it. This should be a struct, and we skip past it. And actually, we don't need this here. We can just do this here. And in fact, let's not even set next at all. It doesn't actually matter, but so here, we're right here. When we hit parse struct, we grab the keyword, which should be struct, which, you know, we just assert that we grabbed a keyword that is struct. We create a node for this struct on the AST, and we look at the next token. If it's an identifier like this, cool, it's a name struct, otherwise it's anonymous. If it's neither of those things, there's a problem. We peek at the next token. If it's a semicolon, this was a for declaration, which we don't even really support anymore, but that's fine. But we early out at that case. Otherwise, if it's an open paren, let's parse all the parameters. I mean, that seems okay to me. We're still gonna fail at... Oh, wait, we didn't fail... Do I parse that yet? Really? Is type arg. Oh, I do. I already parsed that. I took care of that already. Okay. So we're actually failing here. We actually did parse this whole thing. So let's look at the tree and see what that tells us. Oh, wait, no. Never mind. We're not getting the tree yet. It's failing here. So... Okay, that's because when we parse functions, I'm pretty sure when we parse functions that are templates, that have these any ofs in them, I believe that we flag them in a specific way to where they aren't generated as code. Function decal. So is that, where does that happen? Let's look at codegen really quick. Decal function node as string. Decal function. I actually don't know where this is happening, so let's look at the flags on one of these nodes. So nowhere in here. Oh, okay. We have a special node type for function template. In which case, so meta, we need to make another one of these for structs. So struct with any params. So these are struct templates. And let's make another one of these because see. So here's one example where I want these enums, whatever, and I want to be able to print them out as strings, so I just have to have a mirrored string array as well. This is something that the language should really be doing for you, that you can do with metaprogramming, is for any of your enums, just generate the string table of them, and you don't have to worry about that. Anyway, okay, so let's see where we're setting that. Meta function template. Oh, I just realized. Someone just told me that my text is very tiny. That's true, because I haven't been streaming for like a week and forgot that I need to make the text larger. Oops. Well, I'm new. What do you want? That was really bad, though. You probably couldn't read that at all. I did it over here. I did it for the terminal and forgot to do it for my editor. Okay. Meta function template. So let's add this here so we can print them out, and then inside function. Okay, I don't know why those are the only places I reference it here. Okay, I do it in the post pass, so I loop over all my function nodes and update them here if they have a type any param. So I need the same thing for structs. So let's do that. Update type any structs. And really, do functions need to support type as well? So let's do this. We take the whole AST. Let's look for all our structs for each node. It will have param nodes now, which normally structs wouldn't. So for any of the... Okay, you know what? This is a bad name for these at this point, because this can mean a bunch of different things. So let's call this update type any functions to update function templates. And let's do type any structs. This will be update struct templates. And the reason I say that is because, at least in the case of a struct, the goal here is that you'll be able to pass it even something that's not an any. So I should also be able to say this. This should work. And it'll let you dynamically create structs, for example, that have static arrays in them of different sizes. This is not a... So even if it was just this, right? Even if it was just this, there isn't an any happening here, but this is still a template. This is still a dynamic struct that should be generated based on the size you pass to it. So specifically looking for any here is not accurate. So we'll say has templated param for each child node in the struct. If it's a parameter, if it's type any of, or type, I think is what I called it. Type, which is goofy. Type any templated. So, okay, structs can't have ellipsed parameters. Oop. That's fine. And this is struct. And while we're here, let's do the same thing here for type any templated. Let's put this to do here. And okay. Update function templates. Let's do this for structs. Okay. And then codegen. No, wait, that should just work, because we're not going to be spitting out... Okay, I need a case for it. We're just not going to be spitting out struct templates. We compile, and we print out the tree. So let's look at this. Let's go to main. And we should see a struct template. Here we go. AST struct template called any struct. It's got two params. One is a type T. One is an any of. Okay, these should have... Let's fix that really quick, because that's confusing. Param, if its flags is type any, wait, what? Type and any of. Arrow, quote, and then the type. Arrow, quote. Oh, this is in the pointer part. Well, where does that... Hold on. Where does that even show up? Yeah, that's what I thought. Hold on. So that's of type any. This is what I would expect. The name. Am I confusing myself? I think I'm confusing myself. Let's do this over again. Let's do this. And look for main. And okay. The name pointing to the type. Oh, okay. Name pointing to, in quotes, the type. So if the type is a type any, we do this. Otherwise, we print out the type. So I'm wondering why we aren't seeing Because when we do parse variable, we should be setting it here, or here, or here. Let's see. Let's do 2 more of these, and we'll say any of and type. Oh, because that is their name. I do just stick any of and type into the name. So that's what we were saying. That's why. Okay. That's better though. So this is a type T. This is an any of size. And actually if it's any of, how do we store that right now? Let's print all those. Any of. So it's just an array of dynamic strings here. So if it's any of, let's do this. Let's just print them all out. So for, it's a U8, that's fine. Node info decal variable dot any num any of types. Let's write out let's write out the name of that one. And if it's not the first one, if type index, we will also write out a comma space. Yeah? Does that look okay? I think so. But what do we decal oh, missed a type index is less than here. Oh, this is a dot anyway. Okay. Any struct. Okay, that didn't work. If it's an any of, wait, that didn't even work. A little bit. Because, okay. Pay attention. Any struct. There we go. It's an any of. Let's put a space there because it'll just look nicer. That worked though. Any of. So there's that. So size is a type of any of U8, U16, U32, U64. And then this will get replaced via the metaprogram by whatever they passed us in the call site. This will get replaced by the type of whatever this is. And yeah, we just have to generate the structs now. I do believe. I'm trying to think though. Behind the scenes, for example, okay, this is something that I haven't fully thought through, and I was going to kind of just feel it out as I go. So if this is like, if I generate one like this, this will be like, we'll just say U32s, and the size will be 8, right? This needs to generate one that looks like this. You know, something like that. Which is all fine and good, but if I have a function that takes one of these, I don't want you to have to do anything but say this, right? And or will that just work? You'll pass it in any struct. I'll know this is a template, which means I need to generate all of these based on the call site. I think that'll just work. I have to like think through it in my head though, and I haven't done that. It's a little hard to think about until I see it in front of me, so let's just keep going. This will be exploratory for sure. But we do in fact still work, I think. Okay, and what if this is just a normal struct? Just making sure that nothing horrible broke. Let's do this. Oh, right, this is... So field string has... This worries me a little bit. And so does this. It doesn't even know what print is, so... Field str has incomplete type, short string 8. What if these are ints? Interesting. Okay, that works. What happened here? Let's look at the code here. Oops. Any struct? Oh, no, normal. We forward declare normal. Oh, this is not getting depended. Something about this is breaking the dependency map. This should be dependent on short string, and it's not right now. Is that because it's an array? That'll be a bug. So there's that. Okay, now they're in the right order. Now it is getting dependency mapped, but print is not getting generated. Is it because this thing's here? That's weird. Oh, no, it's not weird. This is not how you call print. I am being goofy as hell. That's how you call print. Okay. Okay. But this is still breaking once this becomes an array. That much I'm pretty certain of. Yes. That's breaking the dependency map. Let's go fix that really quick. Depends on... Oh, because it's a pointer. Technically, that's a pointer. Oh, but it's not because it's an array. It's not a pointer. I mean, if this were just like this, then technically this struct would not depend on short string because it's just a pointer. And if it's just a pointer, it just depends on the forward declaration of it. But that's not actually true if this is a hard-coded array size. It doesn't just depend on the forward declaration. So, if A depends on a struct, here. So here I'm saying, okay, do I depend on a certain struct member? If their type matches, which in this case it does, I only depend on it if it's not a pointer. This is a pointer, so I think I don't depend on it, but that's not strictly true in this case. Yes, it's a pointer, but I have to know the size in this case. So... pointer depth. Okay, I don't want to get sidetracked. Should be... fixed size. Okay. I'll come back to that later. That's fine. We just won't do that for now. I know I didn't break anything else, so that's fine. Another bug. Okay. Let's get back our struct here. Okay. Okay. Forget this. Let's do this. Let's do one thing at a time here. Let's do that later. We'll do this one first. Let's just do types first. And in fact, we're going to have to do... No, we don't. We can just say this. We'll just say value. Let's just say whatever type is in it is the one we pass. Okay. Do parse is false. What is this case on 3662? Okay, so here's a case where this is a variable decal, and after the type, we are not expecting a parent open. And at the time, I didn't know if we ever would. So I have this thing here that says, hey, what is this case? I think in normal C, this wouldn't be a case. So, but now it is. So, let's take care of that. So, let's remove this because we're not doing that yet. So this, let's just say we want to have a struct with U32s in it. Let's create you know what? No. We don't need this extra case. We don't need this at all, actually. Parse function or variable decal should be handling this. Or variable decal here should be handling this. So assuming we're here, so next is the type. Okay, here's some, these are special cases, that's what these are. So we look at the type, and then we skip ahead by, we skip all the asterisks and ampersands, because we don't care about them in this yet, determining what this is. So we grab the thing after that. So we grab this as next, we skip over any qualifiers, and then we should be grabbing the name. Okay, so here, actually, we also want a struct template check is, we're going to look at the one directly after. If that is a parent open, then this is a struct template. So we're basically saying if we grab the type, in a normal case it would be like, we grab the type, assuming this was like a pointer, we grab the type, we skip over all the qualifiers, which are parentheses or ampersands and asterisks, then we grab the identifier. There is a case where after we grab all the qualifiers, if the next thing is a parent open, it's either a function pointer or it's an inline constructor. But if we, before we even see that, so if before we even see our qualifiers, if we see a parent open, we know that this has to be a struct template. I believe. That's what I'm going with. So we're gonna say if it's a although, hold on, can I just, let's just flag this here and say struct template. And if it is a parent open, we want to skip until the parent close. So I'm trying to think if these can be dynamic. Like, well, yeah, they could be. So, okay, I can't just skip toward the parent close, because for all I know, you're calling a function in here. So we're going to say parent depth is 1. We've seen one parent so far. Here's what we'll do. We'll keep this skip ahead around, and we'll say this will be skip ahead. Parent depth is skip ahead. No, is 1. We've seen one parent. Now, while parent depth, so as long as we still have parents that we've seen, we will peek token index plus plus skip ahead. We'll just call this peek. Peek type equals token parent open. Then we want to increase the parent depth. If it's a token parent close, we want to decrease our parent depth. And yeah, I think that's it. So, because we will parse this stuff later. Right now, we just want to see what we're dealing with. So, we can store here if we see it, if it's a struct template, and then we just want to skip over everything and then continue as we were doing before. Which is fine. Okay. So let's just see what happens here. Let's compile. This takes the parser. Okay, we loopin' forever. Okay, so parent depth is 1. While parent depth, let's look at the next one. Okay, we go back around. Look at the next one. Next one. Let's just step through this because I don't want to just think my way through this. Linux main line 50. Let's open up VS Code and step through this. Where are we? Parser. Function or variable decal. And let's get to where we know it's a function template or struct template. We should be on line 43. Really? Of what? What is this? Void? Oh. What file is this? This is a false. No, this is in a struct. Where are we right now? Platform DB line 43. Oh, we do think this is a function pointer. Oh, wait a minute. I may have made a bad assumption here. So How do we know, though? How do we know if this is... Let's look at these two things side by side. I need to distinguish between... Okay, a function pointer has to have a star here. This will never have a star there. So... this check can't come here. This has to come here. So parent, if the next type is a parent open, then see, this is a little bit weird. Let's add another, okay, could be struct template. This is a little gross, but let's just assume it could be, unless this happens. If we ever see a token asterisk or ampersand before we get to the open paren, we know it's not a struct template, so we can just say no. And then here, oh shit, I didn't want to lose that. And then here, we can say, if it's a parent open, then, if it's an asterisk, we know it's a function pointer. Else, if it could be a struct template, then we'll do this. And we'll know if it is, if, so now we don't actually need this. Now we can just do this. Right? Okay. I am really trying to reuse all this stuff down here. And to do that and keep this part kind of isolated is a little tricky, so... Basically, if this... Let me see if that fixed over here. If we don't have any struct... If we don't have any of these, are we still good? Yes. Okay, but if we have one of these, then theoretically, we should be getting... Okay, we'll be... Okay, how about we do this? Forget could be... Forget that. We'll just say struct template. And then here, if it could be a struct template and we see a parent open, then it is a struct template. In which case, we don't have to be skipping over anything anymore. So all of this stuff, I think we don't actually care about. I think. This stuff. So we'll just say this, if Okay, yeah. I think I can skip all this stuff. I can just say if after next, if it could be a struct template and after next is a parent open, then it is a struct template. In which case down here, the type is fine, actually. I think we're fine there. I think that just keeps working. I think that just keeps working. So let's just see where this gets us. This is not gonna work, but right, this is not a could be anymore. Yeah. So oh, wait a minute. We already, hold on, this is actually not even true. If the after next is a parent open, we're already doing that. If the after next is an asterisk, otherwise it could be an inline constructor. It could be. But that's only in the case... This is actually more tricky than I thought, because... Do we have any inline constructors? I think we do. I think a short string has them. Yeah, so... This here, for example, looks like this, right? The only difference is I know it's not if we're in a struct decal and this type is the same name as the struct decal we're in. Then I know it can't be. I think. If short string was parameterized, then yeah, anything in here, it can't, okay. Okay, if our context, okay, I need the context for this, so if the after thing is a parent open, then else, if the context is a decal struct, so I don't need this either, so if I see a declaration like this that is a type followed by an open parentheses, that's this. If the next thing after it is an asterisk, that means it looks like this. It's a function decal, or a function pointer, right? If it's not an asterisk, it can be one of two things. If we are in the context of a struct declaration like we are here, this could either be an inline constructor, or it could still be a struct decal with templated parameters, right? But the way to distinguish that is if the name here, if the type name, get token text type, equals the struct that we're in right now. Now, can I get the struct that we're in right now? If the context is a struct, then function decal. I say parse variable decal. But what am I adding that to is my question. Parse variable decal. Create node parser. Oh, I'm returning this back into, oh man. Function or variable decal. I'm doing it here. I'm calling add child node after I already call this. Okay. I'm gonna pass in the struct node here. So parse function or I'm gonna pass in the struct node, I guess. If the context is a decal struct and that we were passed one in and the type of this decal. So if we're parsing one of these things, if we're inside a struct decal and we actually have one to look at and the name of this thing is the same as the struct, it's an inline constructor. If that's not the case, this should be a templated struct declaration. So let's just assert here and just see what happens. Let's remove this for now to make sure I didn't break anything. Get token text. Oh, I don't have type. This is next. Oh boy. Oh. 4 declarations because C and C++. Oh, this is where you do that. Parse function or variable decal. Okay, we still compile, but now if we weren't past a struct node, we should assert now. So in this case, we're not parsing any struct here, which means we should assert false, which we do. Cool. Another case we should assert false is if we're in here and we have one that isn't this short string. That should also assert. Which it did. Let's print out the site though. Let's print out the location info of that node. So no, let's print out what can I print out here? We'll do this. Get token text. Next. I just want to make sure that we're at where we think we are. A space. After next. And why not after next? Why not? Just see where we're at. Assert message. Oh, yep, this is... Oh boy. any struct u32. That's here. If I change this to to dynamic string. Okay, so that's definitely that place. And if I do it here, it's that place. Okay, just wanted to verify that that is happening. So, struct template is true in this case. So when we get down here, we grab the type and let's just see what's happening here, because I don't quite remember how this works. So if I have like this, oh yeah, this will break, huh? Yes, okay. Let's compile this and step through. Let's step through it. So we should definitely hit this at some point, which we do on line 51, any struct. So we do hit that. Cool. Before that, though, let's do this on let's try to break on the X. Which I think is this. Yes, X. Okay. So I just want to see how we're actually doing this right now. So we have the type in type, which is here, U32. Next, so what is skip ahead in this case? It's 1. Right, because it should be the identifier. Yeah. Which makes sense. Okay, and skip ahead, we know how many to skip because all we're skipping in that case are the qualifiers, like the asterisks and the ampersands. But in a struct template, we will have more to do. So let's go here. So type should still be correct. Type should be the any struct, which it is. Next, though, should be an open paren, which it is. Okay. Now we can do this part. Now we can say if struct template we want to what do we want to do here? We want to okay. We need a new node type in here. So the way we know how to generate functions is through this function call. We need a new one here. We need a new expression that's like struct template call or something. Or just struct call. Is that too ambiguous? I mean, I'll put a comment here, but I think that's okay. Custom expression for nodes to signal. It's probably okay. We'll just call it, we just want it to match because we have function call, macro call, constructor call, snippet call. We'll have a struct call. Generate a struct call here. And struct calls, can it just use this type name if constructor? A function call will have a name and parameters. Actually, I don't know if this is actually the right way to do this. Because this is a decal variable, right? I feel like this might actually be a property of the decal. Maybe? This is a struct template call. You know, something like that. So if we have that property, it's a struct template call, then that will be part of this decal info variable. Do we have everything we need here? It'll have a name. Let's look at this again. It'll have a name. It'll have a type, which will just be this part. And this type node will get linked back up to the template. It'll still have a pointer or reference depth. It can still have flags. And then its children will be the params, and then I think this will work. I think this is how we want to do this. So it'll still be a variable decal. It'll just say if it's a struct template, then well, flags. What are we doing with flags? Yeah, okay. So if it's okay, so did we pass those in? We did. Okay, so we'll just say flags. We can OR in this new one we made. If it's a struct template, then we'll say this is a template call. No, so we don't want to do this. Tag it and add all of its parameters as children, just like a function call. Okay. So we grab the type. If it's a struct template, let's skip the open paren, which at this point we should know it's there, but let's just assert that it is. Current is type. We expect a parent open, and we're in an AST decal variable. So we expect an open paren. In fact, let's do this. We expect the next thing to be an open paren, and we tell it we're a function template call. Now let's skip it. Okay, and now we can just go expression by expression, I guess. Oh, we can just use the function call params, I think. Parse function call params. I think. What does parse expression do, though, if it's a type without a name? What does that do? If it's a literal, we don't care. If it's a keyword, if it's a fundamental type, an identifier, or a preproc, then if it's a known type, if it's an open paren, we're calling a constructor. Which is true. Otherwise... Oh, this would... Oh, no. If it's a known type... Pass to a macro. Create decal ref node. It's right here is the problem. So, if we see a known type... If what comes after it is an open paren... This is almost certainly a constructor, right? But the problem with that is that's no longer true because, or no, that is true. It's a constructor, but if it's not an open paren afterwards, like in this case, we're passing it a known type without an open paren, which means right now we're just assuming it might just be a type passed to a macro. But in this case, it's a type passed to a template call, which maybe that's fine. Do decal refs point to types already? I may have to handle that. This is... Well, no, actually, this only matters if it's a fundamental type. I think. No, if this is literally the type, like passing U32 to a struct template, necessarily be pointing at nothing. Okay, we will definitely hit that, but so for now we just create a decal ref node. Actually, you know what? What happens right now if we do that? Let's just see what happens. If I have a macro that's like, and it takes a type, and I say type x equals 5. Can I just say test U32? Does this work? X. Unable to resolve type for parameter X. Oh. I think I don't actually support macros anymore. Right, I don't even support macros anymore. This might actually be easier because I decided to make that step. So if this is a snippet though, I kind of replaced macros with snippets here. So if I do that, What does that resolve to? So if you don't know, a snippet in this language is basically a macro, but it is very rigidly defined like a function is, and it still does the replacement. So like I can pass in whatever I want here, and it'll replace this here. But unlike a macro, which just does a textual substitution wherever you call it, this is parsing this whole thing. So like here I'm calling with U32. It will create a copy of this, plug in my thing, and replace type with it, and then parse it as actual code, and create a node on the tree for it, and then replace this function call with that node, like as code. So it's like type checked and all that stuff. So it's just like macros, but they're type checked, basically. They're parsed and type checked. So I actually don't know what this will do. Type was not declared, so okay. So let's see what that generated. Actually, I'm curious. Test. Or no, it'll be in the snippets will show up here. So let's go to main. Okay, so it is type here. I'm saying type. Do I not support this? Really? I don't have to do something weird like that, do I? No. I thought that worked. Okay, what if I do this? U32 type. We'll call this type. And we'll call this X. Does that work? Yes. Okay, so I'm not replacing... I'm just not doing... Let's look at snippets. Update snippet calls. Where is that happening? Is that here? Do I have the project in a public repo? I don't. I think long term, I will probably make this public. Right now, I am just, as I'm still heavily work in progress and kind of just exploring things. It's just private for now. I don't really know what the future holds for it in that sense, but I am not against making it public once it's in a better place. So still early goings. So okay, these are the calls. If the snippet has no parameters, the symbol copy. Okay, so it does have parameters. We need to do some extra works to decal refs. Update snippet call nodes. I think that's what it is. That's a bad name for this. We need to update all the decal. This is it. This is a bad name for this. This should be like snippet copy decal refs or something. Okay. So for each, so we have the copy of the whole snippet. We look for a, oh, okay, we're looking for decal refs. If the variable is declared the same as the parameter, we want to use the type name for the... Aha! So we actually are doing this for the variable name right here, but I don't do it if you're using it for the type, and I totally can. I'm surprised I wasn't already. So, snippet param for variable. Snippet param for variable. Let's see. Snippet param for variable. For each child node of the snippet, if the child's type is a parameter and the name is... Yeah, so I'm saying, okay. So, snippet param for variable. Let's do this. Let's create a snippet param for variable result. This is all going to get cleaned up at some point, so I'm fine leaving this here. So this is going to return the snippet param. And it's going to return the we'll say like what matched, I guess. This will be a match name, match type. That's like overkill. I'll just mark it here. That's like super overkill. There's only two things that can really match here anyway, so okay, so if it's a parameter, then if this returns a snippet param variable result. If the name matches, then we return child 0. Actually, we'll flip these because that's the order they come in. So we'll say type name. This will be 1. If the type matches, we return 0. So then here, matching param is a snippet param result. If matching param, we'll call this node. If we got one back, then snippet param index for string. Right, because we have to match it back up to... We need to match it back up to what was passed in. Which means... We're doing it here by the name. Let's see what that's doing, actually. So, index for string. Okay, so we will just say if We'll say short string equals matching param what matched equals 0. If it was 0, then this thing will be the type. Otherwise, it will be the name. So we'll pass the string. If we find a valid one, we grab it, and if matching param what matched is 0, we'll do the type. Otherwise, we'll do the name like we're already doing. I probably screwed something up here. This is the type. Okay. And just to future-proof this, in case I ever want to do anything else here, okay. This is the name. And 1. Okay, let's see how badly things are screwed up. 1054. Right, this is nothing. Well, that's a good sign. We still compile. Oh, we still compile. And this is in the right place. So if I look at the... let's look at main. X equals... It's a U32. That worked. If this is a U8 and I have this be type, this will fail, won't it? Unable to resolve type for parameter X. What did that generate? It's a U32. Oh, it failed before it even tried to generate it because it doesn't know what X is, obviously, because I'm not defining that anymore. If I define X through the snippet, that also works. Okay, great. Great. So that works again. And why did I want to do that? Because... Right, I wanted to see why... It's likely a type being passed into a snippet. Treat it like a decal ref. So... What is this actually doing? It's creating a decal ref to what? Let's just print the result and just see what the hell that is. So, oh, should probably keep that, huh? Oh, but this is this is for expressions. You're not going to get an expression. This is not even the right place for this. Is it? Yeah, it is, because this looks like a call, just like this does. So how do I differentiate between these two things? Should that not just work? I'm confused. Let's not print this out anymore. Let's print out the tree and look at main and just see what this is doing. Oh. we don't even see the snippet call. It has already, by the time we get here, it has replaced that snippet call. It's replaced it entirely with the contents. Okay. But it is a snippet call at one point, is it not? It is. No, it's a function call. It's a function call. Right, and a function call can't be a known type. Ooh. Also, how does that handle this case? Let's look at this again. Let's make this a U32 and instead do this like we were doing before and have this. Okay. This compiles, right? Yes. And what does this look like? So that's a snippet call, which initially is a function call. So it sees this as a function call right here. Why? Because okay, maybe I just handled this already. Maybe this is fine. This might just be fine. I might already handle this case sufficiently enough for this to work. Expected parent open after any struct got. Oh, I must not be skipping something. Parse variable decal. Here we go. So if type arg is type arg, so when I parse a variable decal, we are here. Wait a minute. Parse function or variable decal. If I know I'm a struct template, this is named poorly. This is not doing any actual parsing. This is asking us, what is this thing? At which point another function does the... Okay. So forget this thing. If right, because this could be a function decal or a variable decal. If I am seeing a struct template... Okay, I have confused myself with the naming of this function. This function's job is not to do any parsing. It's to figure out what it is we're parsing, and then it will either call parse function decal or it'll call parse variable decal. Right? It determines what the hell am I looking at, and then, okay, we're either going to parse a function decal or we're going to parse a variable decal. So by this point, I only care if it's a struct template insofar as I want to skip over things. So so this is still fine, but I shouldn't need any of this stuff. We're just gonna say if the next thing is a parent open, if the thing after that is an asterisk, it's a function pointer. Otherwise, if it's this, okay. Otherwise, we just want to skip past struct template decal, skip past the parents. So the thing I wrote before is actually what I want here. And I have already gotten rid of it, but it's fine. So, okay, we're gonna say parent depth is 1, while parent depth peak is peak token index plus plus skip ahead. If peak type is a token parent open, we're going to increase the parent depth. If it's close, we're going to subtract the parent depth, and that's it. So we're just going to basically skip over until we're out of the parens, at which point, okay. So we're looping forever. Does that make sense? Well, let's see. Let's see if we get here. Parsing variable, and then in parse variable decal, we will say inside parse variable decal. So let's see if we get here when we freeze. And in fact, let's also print out the type, just cause. Let's just see what it is. Okay. We don't know what it is. That's fun. How did I get the two L-shaped cursors? This is... Oh, I guess I realized I don't have this on my YouTube, but I do on my Twitch stream. I'm using an editor called 4Coder. I can send you a link to it. Here, I'll send you a link to it. This is the editor I'm using, and that's just what its cursor looks like. So, like, if you've ever used something like Emacs, there's where my actual cursor is, it's what's moving. That's where if I type, that's where the stuff comes out. But then there's also this mark that is left up here. I can move the mark whenever I want. And the space between my mark and the cursor... Oh no, yeah, this is 4Coder. It's very Emacs-esque, but it's an editor called 4Coder. So, if you know about Emacs, I don't have to explain the cursor to you. But yeah, that's just what this editor. That's how it draws its cursor. So, yeah. And I guess for anyone who doesn't know, yeah, it's just like it's like the selection. Like if you were to select text normally, you have like a start and an end. It's like that, only it's doing it all the time based on where the mark and where the cursor is. So, so like if I'm up here, if I place my mark here and come down here and hit cut, I cut everything in between there. So, yeah. So, why are we not seeing a type token for any of this? Oh, okay, that's a specific case. Let's print it down here. Instead of type token, it'll be type. Yeah. So, where are we at? We're stuck after this, which is type, int, and character. So, type should be this thing here. I'm not sure where the int and character are coming from. So let's also output exiting exiting and exiting. Let's just see. Okay. So we are not getting stuck inside of here like I thought we were. We're getting stuck maybe inside of there. That's here. Finishing variable. Yes, we're getting stuck in, well, hold on. That's not true. I'm seeing this, but not this. Because we're breaking out. In fact, that means this should just go outside the while loop. Okay, we're getting there from somewhere else and we're breaking in a separate place. So we're actually parsing the type thing just fine. Okay, let's just see what's happening here. Let's just step through it. Instead of doing all this guesswork, let's step through it. Parsing variable. Okay. Let's get rid of these breakpoints and just run it. And pause. What? Okay, yeah, we're stuck in a loop inside of do parse here. So if we go back to do parse, let's go back here. Okay, let's see where we're stuck at. Next is any struct. That's a good sign. So we are stuck right here. After next is a parent open. So if it's a known, if not a function or variable decal, it is a function or variable decal, so we go in here. Next is identifier, any struct. There's no tokens, ampersands, or... Oh. This does have to come before that. That's not what's happening here, but if there were asterisks or ampersands here, they would be coming over here, which is after we skip over these. So that's not the problem here, but I feel like I should fix that right now because that's going to complicate this function's logic to the point where it might throw off the rest of the debugging. So skip ahead is 1. We can do this. Okay, so we look at this. The next thing is a parent open. If it is, then let's go into it, and if the next thing is an asterisk, it's a function pointer. Otherwise, it's an inline constructor, so we just leave in both of those cases. But if it's a struct template decal, we go past... Okay. Ooh, actually, you know what? We just have to do this in both places. There's probably a cleaner way to do this, but we just have to do this in both places. That's fine. It's a little gross, but it's fine. Okay. Back to what we were doing. Let's do this. Let's remove all these because I don't even know what they are. Let's go until we're looping, and now turn this back on. Okay, we should be on any struct. Starts expression. Oh, I didn't want to do that. I wanted to go here. Next is identifier any struct. We have nothing to skip. This should take us here, which it does because we're passing a U32. So okay, so we skip the parens. We shouldn't see any open ones. Okay, break out. We skip more token asterisks and ampersands if they're there. Joel T, if you look at my YouTube channel, so the last video I just uploaded a day or two ago kind of goes over the, like where the metaprogram sits. It is not a library. It's basically another program that you're running. You're basically compiling the metaprogram as C code, which is spitting out a binary, and then you run that binary while pointing it to your source code, and it's going to spit out a bunch of code for you. So when you see me compile, there's the compiling metaprogram step, and then that's spitting out a binary. It's then running that binary, but pointing it toward your actual code base to generate a bunch of code. And it's not doing anything after that right now because we're in the middle of working on it. But after this step, you will now have a bunch of new code in your directory that then gets compiled as your actual program. So it's compile meta, run meta, generates code, compile main, run main. So it's really compile, run, compile when you build. So it's not really a library. It is a totally like separate system that you're running. It's a little hard to explain. I go over it in that video, the last video I uploaded. Definitely recommend watching that if you're interested. So let's see. So it actually already does write C files. So if you see here, all of this code on this right hand side, this is all being generated for me. I didn't write any of this. It's not really an AI, it's just C code that I wrote to spit this stuff out, but it spits it out dynamically based on what's in my program. Again, that video goes over it in a lot more detail, so I definitely recommend watching that if you're new to these concepts. Okay, so now the type we should have, it should be any struct, right? Type is any struct, and then okay, we didn't do anything in here. That is why. We didn't do anything in there at all. So let's see where exactly we're breaking down here. Okay, we skip the parens. Skip those. Type. Okay. Type and next. Type is any struct. Next is the parent. Oh, I didn't actually skip the parent close. When we do this, skip the final closing parent. Plus skip ahead. Because we're stopping on the closing paren, we want to then skip past it. This is probably still not going to work, but that was at least causing our... Yeah, there we go. That was causing us to just sit there and loop forever. So now let's see what our problem is. So now we're saying... now we're actually failing... But we are failing to parse a variable decal, which means we're getting out of this function or variable decal function, and we're getting into We're getting into the right place. We're getting into this function, parse variable decal. So that's progress. Expected. So error. Let's go to expect token. So we're expecting a identifier. So that's happening here. So let's go to parse variable decal. So we're failing when we expect a... Oh, you know what? That's not how that works. Let's go to expect token. No, it's parse error, right? It's been a while since I've been working here down in the parser like this here. So if we hit this is when we failed. Yes. So let's look at the call. Here we go. So let's break when the token cursor is 106, I guess. No, let's do it up here when yeah, token cursor is 106. Next is no. What? Oh, type. I'm looking at type. U64 on line 32. Nope, that's not here. Where are we? How did we end up here? This is in string builder. That's not right. But then we end up here. Token cursor is 106. Okay. So when you break here. Okay, let's break. That's confusing me, but we'll say token cursor, and then the current lexer is also. So let's remove this. 145. Parser and parser cur lexer num tokens equals 145. Arg, that didn't actually work. I don't have a great way of breaking into the middle of the parser like this. It's actually really frustrating to break right where I need this to break. So actually, let's do it this way. I know that I need to break here when I expect an identifier, so I'll just say if peak token parser type is not a token identifier, we'll just make a variable and I can break there. Yeah. Parent open, type is any struct. Okay. So why didn't that work before? 106, 145. I don't know why that didn't work before, but whatever. Okay. Okay, so at this point we have created a variable decal node. It has a type of any struct. That's good. It's not an any of. It's not an ellipses. So, oh, right. Okay, now we just need the logic here for handling, right, because the logic for handling this is not in the function or variable decal function, it's in here. So if we get here and the if, so we'll say next, although wait, next is the name of the variable. Yes. Yes, so if the next type is a token open paren, so if we see an open parentheses after the type, like in this case, the type is any struct. If we see an open paren here, and we are in parse variable decal, the only thing this can be currently is a struct template. So we want to skip the open paren. Okay, and now, wait, no, we don't want to do that. We want to call parse decal, or parse param decals. This, we want to call this. And this does assume that we're after the open paren, so we do want to skip it, and then we just say parse param decals parser on the variable decal. Will this just work for me? Do I have to not do anything else? That would be nice. Skip the open paren and parse the... I don't even need a thing there. Let's just say skip the open paren so we know why that skip is there. Okay. And then we grab what's next and keep going. Honestly, I think that just works. Do I have to skip the closing paren though? Does this skip it for me? No. So this expects me to skip it, so skip the open paren and skip the close paren. Okay. So that might just work. I'm not going to say we're going to run, but that might just work. This has to come first. It can't come first because it needs parse variable decal. So I need this to go up here because C and C++. Okay, we're not looping forever anymore. Third argument of main. Why is there a third argument to main? Good question. Where is that coming from? Third argument of main should probably be char star star. What is happening? That's some wacky error messages. We are adding a third parameter to main. So that's not great. But we're only doing it at the forward declaration. Interesting. And then we're adding an equals U32. There's some weird stuff happening here, I admit. I don't know what's happening quite yet, but we'll get there. Okay. Where am I? Okay. So, let's just step through it, because we know we're at least hitting this now. So, let's go here. Actually, let's remove all these, because I don't want to get confused. Okay. So, if next was an open paren, let's parse the parameter decals. So what we should see here, here's our variable decal node. Here's the node we're creating on the tree for this. It should already have its type, which is any struct, which I think we already verified it has. Here's the type, any struct. You'll see it has no children yet. What this should do, this function, should add a child for every parameter we passed, theoretically. So after we go past this, there you go. It was passed a param whose type is U32. That's great. That's exactly what we wanted. And normally, variable decals don't have children. Like, well, they do. They have one child, which is the thing. So like, if I did this, the node would be a decal variable called x, whose type is U32, and it has one child. No, wait, that's not true. This, on the tree, and I'll just show you this actually. So, on the tree, a variable decal normally looks like this. Main.db. So normally a variable declaration looks like... Oh no, it is. Okay, I was thinking of assignment operator. That's not an assignment operator in that case. That's just a variable decal. So we're saying it's a variable decal. X, its type is U32, and it has one child, which is the thing that you're setting it to. It doesn't always have that if you're not giving it a default value. So in this case we're giving it a value of 5, so it's the first child. If what we're introducing now is if it's one of these struct templates, so you can see here the way a function call works is the first child of a function call sorry, the first child of a function call is the name of the function that you're calling as a decal ref, and then it's all the parameters after that. So here it's a function call, we're calling free memory arena with arena temp. Function call, free memory arena, arena temp. We're gonna do a very similar structure for calling struct templates. What this should do is have a decal variable who has a name and a type, but its first children will be let me think how this is going to work, because how am I going to know that this Okay, I think we already solved this actually. This decal variable will have this on it. It'll have this flag. So if I check this flag, I know that we're instantiating a template call. That's how I know. And I wonder if I should introduce another node type here that's not param, but is more specific, like No, actually. No. Sorry. Yeah, I don't know exactly how I want to do this. Because I still won't know which of these things. I don't know how many. I guess I will, though, right? So if I see one of these, if it has this on it, then that means this type node is going to point to the template that it came from, which tells me how many parameters it should have. So I will, in fact, know that. So I know that how many children I should skip before I get to the assignment is whatever the template tells me it has. I think that's fine. I think that's fine. I think we're crisis averted. I just had to think through that. So what we're going to say is, where are we? So I don't need this. I need right. So property type. Am I doing that anywhere? Is type arg? Oh no, that's not what I called it. It's property struct template call. Property struct template call. I'm not doing that. So here's where I do that. So if we see one of these, we want to flag info decal variable flags. We're gonna or in this, so we know that's what it is, and then continue on like normal. Yeah. Yeah. Okay, let's continue to see where we're at here. So we're here. It's children. Ooh. That didn't work this time. What? Hold on. Here's the decal node. Children. Okay, that did work. But it's a param. Why is it a param? Decal param. Where is that happening? Oh, these aren't parameter decals. These are... Hold on. Function. Parse function call params. I'm calling the wrong function. I want to call parse call params. Parse call params. Call params. Did I rename that function erroneously? Parse param decals. Parse function decal params. Yeah, I did the wrong one. Oh no, I didn't. These are two different places. I have to parse these and these. These are the decal params. These are the call params. We're fine. parse call params. God, I'm getting confused. It's okay. Function call params. Okay. Call params. So, parse, we'll say property type struct, what did I call it? Property struct. This is not param decals, these are call params. Okay. And just for consistency, this is not the function node anymore. This is just the parent. Okay. Expression function call. Okay, this is no longer this. We need to pass it the context. So we need to pass it the context, parse call params. In this case, it's an AST function call. In this case, it's a function call. In this case, it's a variable decal. Did I do that for the other one? Param decals? I guess I don't error out here, so that's fine. Okay. Parsing function call. Expected open paren for function call. Got U32. So it still thinks this is a function call, which is interesting. Let's figure out why that is. Okay. Man, it got late. Why are we thinking we're a function call? How did we get here and think we're a function call? Or is that even what's happening? Yes, that's what's happening. Okay, we're getting here. In what world do we think we're a function call? Oh. No, how, okay, hold on. So, parse the call params. Oh, we're failing in there, that's why. We are now failing in here, because parse call, because again, I thought we were calling a different function. Parse call params. Note assumes the cursor is before the open paren. That's why. So parse call params, and this is not function call. Expected for call. Call params. So we don't want to skip the open paren here. We just want to do that. Okay. Wait, parse call params. Does that skip the closing paren? It does. Okay, I don't have to do, I actually don't have to do this either. I just have to do that. Cool. We are past all the parsing problems. Now it's the codegen side that is screwed up, which is a good place to be in. So if I look at the tree, variable decal called myStruct. It's an any struct, and it has one parameter to U32. That's what we wanted. So, cool. The next step now is on the codegen side, and the post parse step and the codegen side needs to recognize this as a case where we have to go generate one of these. If we see a variable decal that has this on it, this property, then we need to do some generating. That's the next step. And it's late enough. Probably won't start that tonight. Let me add some to-dos in here. If there are any questions, because I do have some people watching, which is pretty cool. If there's any questions, let me know about what went down tonight. I can try to answer. While that's happening, I will add some to-dos in here. Left off. Parsing seems to be good. Now on to post, pass stuff, and codegen. Just to make sure I don't miss this. Progress on struct templates. Struct template progress. Parsing. Okay so far. Next step is post, pass, and codegen. To-dos. Okay. No questions, that's fine. Not a ton of people watching. No big deal. I will call that a night, I think. Thanks for watching, and we'll see. I'll probably be streaming tomorrow too. I really am excited about getting the struct template stuff done. I am foreseeing a lot of problems ahead pertaining to wrangling the names and hooking everything up properly, so that way if you have a bunch of struct templates that you instantiate and you have a function that takes a struct of that type, it should just take that base struct and work for any version of it you instantiate. That is the current goal. So what has to happen next is recognizing those nodes in the tree that are structs that need generated, generating them, and also recognizing function calls that, or function decals that take function calls to functions that take those structs, and generating calls that will take that specific kind. It's going to be wild. But I'm 90% confident we'll get there. So once again, thanks for watching, and yeah, I will see you soon.